Well, thank you very much. And Allison, can you give me like a 10-minute warning? Because sometimes I get out of control and I don't want to do that. So thank you very much. Thank you, Simon and Allison, for the invitation, and everyone else for great talks. So my subject is about the world and why it's messed up and how we can try to make it better. And I've actually worked on a lot of different transnational global issues, and I'm trying to pull out from this larger body of work some insights into what works and what doesn't, and also why. So that's what the talk is about. So for people, I mean, you're all proper scientists. I'm an economist, so a different category. But you probably see the world this way. You see this beautifully complex world and try to understand the natural and physical systems and so on behind it. And the reason that we're messed up is partly the way that humans are organized. And we're organized in this geopolitical sense with states, nation states. And the problems originate basically from us. These are the problems I'm going to look at are self-inflicted. And these are problems that we cause because of the way we're organized. And they're problems that we have to solve or at least improve upon. So we have to look for the source of the problem and the source of the solution. They have to be compatible. By the way, because I'm an economist, I don't have beautiful landscapes and wildlife and smiling children and so on. So forgive me a little bit here. But the classic depiction of the tragedy of the commons, which everyone is familiar with, is the Prisoner's Dilemma game. It's actually not the best game to explain the tragedy of the commons, but this is what people do, including Lynn Ostrom, and I'm going to follow that because it's going to be useful for the talk. So this is the way to show the game. This is what the other players are doing, and you've got some number of players, n, and on this axis, this is how many others are contributing to some global public good. So they may be reducing their emissions of greenhouse gases. They may be cutting back on their harvests of fish stock. And this is the payoff that in this game you can either cooperate or not. This is the payoff you get if you don't cooperate. This is the payoff you get if you do cooperate. And what you care about here are your payoffs. And what you see is the payoff to not cooperating is always bigger than the payoff to cooperating, given what others are doing. So just take a vertical line up here. The red line's always above the green line, and that's the basic problem. Now, if everyone pursues their self-interest, they're pushed into this, they almost can't help it, but they're pushed in the direction of not cooperating. But everyone's better off if they do cooperate, and they know this. So when I say they're pushed in this direction, no one feels good about it, because they realize that if they all behave in that way, they're all worse off. So the reason the game is nice is because you're torn between these two places. You're drawn in this direction by self-interest, but you're drawn in this direction also out of self-interest in the sense that you know that you're better off if everyone cooperates, including you. The problem is, if everyone else cooperates, you're even better off by not cooperating. And that's why there's this tension in this game. And this explains, I think, a lot of behavior that we see. Now, this place that you're drawn towards, which is a bad outcome, the payoff there is quite low, the payoff here is quite high. This is called the Nash equilibrium of the game, obviously named after John Nash. It used to be people didn't know very much about this, but now Hollywood has told us about it. Here in this table, I'm showing you how to think about the game. The Nash equilibrium here is unique. There's only one of them. There's a dominant strategy in the sense that because these lines never cross, what you want to do doesn't depend on what the others are doing. The red line's always higher than the green line. So you have a dominant strategy, which is not to cooperate. And the equilibrium is not efficient. It's not efficient because the payoff here is a lot lower than here. And finally, it is symmetric because in this game, all the players are the same, and they all behave in exactly the same way in this equilibrium. So that's the basic theory. Now, when you look at real people and how they don't play this way. This is a game I've done with Astrid Dannenberg, who is someone I've written many papers with.
What's the definition of efficient?
Efficient, well, this would be a Pareto efficient. So it means that if this is not efficient because there's another place that's feasible in which everyone's better off. Yeah. So it's actually, there's no argument against where we should go here. There's no moral philosophic argument that could argue for any other place than that one. And everyone knows that. If you play games with people, they know this very well. They know they're all much better off here. It's just that the incentives are also pulling them in this direction. So when you play these games with real people, this is a game we're playing with real people, and the groups are with 5 people, and they're playing over 20 different rounds. And they play, they get to communicate in some way. They play 5 rounds, then we stop, they communicate again, they play another 5 rounds, stop, communicate, play again, and so on. And what happens is, initially, there is some cooperation. This is absolutely classic picture, by the way, more or less. It's absolutely classic. There is some cooperation, so 3 out of the 5 people are cooperating. But then the next round, it's 2 out of 5. The next round, 1 out of 5, and then it goes to 0. And then it stays at 0. But then they get to regroup, the triumph of hope over experience. They try again to cooperate, because they know they're better off cooperating. But now only 2 cooperate, and then 1, and then 0, and then they regroup again, and now only 1, and then 0, 0, 0, and then finally everyone's 0. Now, it's very popular today to say that the prisoner's dilemma is actually not a very good description of how people behave, because you get behavior like this. People do cooperate, but remember that an equilibrium means that given what others are doing, I don't want to change what I'm doing. This is not an equilibrium here, because that's why behavior is changing in this direction. Given what others are doing, you're actually better off by not cooperating. So that's why it draws down. And the fact that you're converging towards something that's very close to the equilibrium is actually consistent with the equilibrium. Now, why is it that you see that pattern of behavior, though? So we're trying to understand what real people are like, and I'm going to scale this up later to the state. And what we really know is that some people are conditional cooperators, meaning that they will be inclined to cooperate, and they will start off by cooperating, provided others do. But as they see others not cooperating, then the cooperation starts to fall apart. And there are 2 things that happen. One is that the people who are conditional cooperators, let's suppose we're making contributions and someone contributes $100, and I may respond by contributing as well, but maybe not the full 100, I may only contribute 90. And that person, maybe I started off contributing 100, and that person also will respond by 90, and then next period it's 80. And so that tends to come down, even when people are conditional cooperators. And on top of that, you have some people who are free riders. They just go directly for the Nash equilibrium, as it were, and they pull everyone down. The other people don't want to cooperate because they're basically bitter about the ones who are not cooperating. It's very hard to hold the whole thing together. Okay, now what helps in these games? You have to change the rules of the game to get behavior to change. And one thing you do is have communication with the players. And the communication can help. In some games, it helps a lot. In this particular game, it helps, but it tends not to help for very long. So you can get some cooperation, but there's still this pressure for cooperation to decline over time. Another thing you do is you can impose punishments against the players who are free riding or not cooperating. The problem with the punishments is they do raise the contributions that everyone makes, but to work, they actually have to be imposed. And the punishments are costly, both to the player imposing the punishments and to the player on the other end. And so what happens is the payoffs don't go up. You just have a lot of people punishing each other. And what's even worse, if you let everyone punish everyone else, they end up punishing all over the place. And you're actually, believe it or not, you're actually worse off with the punishment than if you had the game without punishment and you accepted the free riding. That's how bad it can get. So people can be really troublesome. Now, it's because of this, of course, that Thomas Hobbes wrote his book Leviathan in 1651, where he argued that to overcome these kinds of problems, you need a sovereign. He's thinking about a sovereign a state, or actually probably literally a person. And that was to keep people, I think, by the way, the original said men, and I took your cue and made it people, in awe, and tie them by the fear of punishment to performance of their covenants, meaning their agreements. Sorry? Okay. Okay, very good. And actually, Garrett Hardin and Simon talked about his work in the introduction. Garrett Hardin said something very, very similar to this. Basically, what he's arguing is you need a state who's going to intervene and help us to overcome our own negative tendencies. By the way, that's why we have states. That's why they exist. We construct, and I think one of the greatest achievements of Homo sapiens is to create institutions to overcome our own failings. That's one of our great achievements. Now, Lynn Ostrom is famous for having a different view, although it's not, it's quite sophisticated in a way, and that she doesn't think it's necessarily, first of all, she thinks that having the external party in force, you kind of always trust the external party. They may be corrupt, they may be bad characters, and so they're all, just relying on a state raises a new set of problems. And on top of that, she has evidence that people are able to cooperate in some settings. Now, in this article, which was about global problems, she and her co-author say that, well, sometimes people do well in these groups when they're left on their own, living within a single country. And I think what's going on here is that these are people who, of course, know each other. It's more likely to be within a certain country. But also, often the state is playing a role. It's just kind of a backseat role. For example, the state may say, this resource belongs to this community. Now you sort it out. But if that's the case, the state may be preventing non-community members from intruding. Okay? So there may be a role of the state that's kind of hidden. It's in the background. Anyway, she also says that for the global problems, it's a lot different and harder, partly because of the scale, partly because the world is so much more diverse. As you move further and further away from your circle of contacts, you find there's a lot of diversity. And finally, and most importantly for what I want to say, under the rules of international law, which are the rules that we have adopted, the institutions that we have adopted for interacting with each other at this international level, you have a basic rule that joining a treaty or an agreement or a covenant is voluntary. It's not a democracy. If the majority of countries say we should do something, they cannot impose their will upon the minority. So it's not like a country. That's how the international system works. And we have to figure out how to get this system to overcome the problems that I began with, the problems of free riding. Now, Lynn also mentioned, and Simon said this in his introduction, she also, with her husband, Vincent, developed this idea of polycentric governance, which means that you have not only the international governance up here, but below that you have the states, and below that you have like states within the states, and so on and so forth, all the way down to us as individuals. And we're interacting in all these kind of complex kinds of groupings and organizations all the way up. And if you look at a problem like climate change, you see there's some action at the highest level, the Paris conference, I'm going to come back to that. Some action by individual countries, like the United States, Canada, et cetera. And then below that, California's doing something, British Columbia's doing something. And then below that, you get other actions. And then even within our own homes, we're doing things. So you're getting all of that. She's actually, in this article, I think very good at saying this is not a panacea at all for these kinds of problems. And she said she expects that with free riding will be an important problem for this. So this polycentric is not meant to be a substitute. And I actually think that what is going on, when people see the so-called polycentric governance, which a lot of people are very cheerful about, I think you should ask the question, is that actually a good thing? Or are we only seeing that because of failure at the very top? And if the top had succeeded, the other things would have been you wouldn't have paid much attention to them. So in other words, I think what we're seeing is these other levels of organization responding to the failure. And it's actually not, this is not a substitute for getting it right, if that's possible, at the higher level. So that's what I want to focus on, the higher level. Okay, so now a little simple game theory. I may regret this. How you think about a treaty. So I'm just going to lay out how you think about it. I'm not going to do any mathing. How you going to think about it. So we're going to look at a stage game. And in the first stage, the countries, which are all sovereign, they get to make decisions for themselves. They decide if they want to join this agreement or not. Do we sign? Do we ratify? Second, those who are in the agreement decide what the agreement should look like. What is it that we should be required to do? And then finally, the countries that are outside the agreement decide what they're going to do. And when you solve this game, the countries that are outside the agreement are in a national equilibrium in the sense that they wouldn't change what they're doing at all. They could not make themselves better. The ones that are in the agreement couldn't make any change to make the agreement better. And all the countries that are in don't want to be out, and all the ones that are out don't want to be in. So you have a complete equilibrium. Okay? Now, if you do it this way, you go back to the picture I showed you before. So the underlying game, as it were, is the prisoner's dilemma, the one I showed you before. But what the treaty does as an institution is it brings about a twist in the payoffs. So they look a little different. So this red payoff curve was the same as before, and it would have gone to here. But now what happens is the treaty only enters into force if you have K-star parties. It's exactly at that level where those countries are willing to clean up their pollution, let's say. And of course, the non-parties are free riding. So what happens here is you do get some level of cooperation, okay? It's better than before, but it's not as good as you'd like to get, all right? Now, the ones who are in a sense making a sacrifice for everyone else, and the ones that are out are free riding. Now, the gain you can get from this kind of agreement is actually very small. If you have a large number of countries, you have two situations. One is very few countries are in the agreement, in which case, obviously, they can't do very much to help because they're just a small part of the problem. They can't solve the problem on their own. If you have a lot of countries that are in the agreement in this self-enforcing agreement, then it has to be the case. The only reason that you have a lot of countries in the agreement is because it would only pay them to cooperate if all of them are in there, or a large number of them. And then by definition, they can't improve much on what would have happened if they did not have an agreement, because they're just better off having it than not having it. So this approach means you can never get very far as long as you have a large number of countries. This is a kind of a negative result, although if you hold it up against what you see in the world, it's actually pretty consistent with what we see. This game is not a prisoner's dilemma. The treaty has transformed the game into something different. This is called a chicken game. And in this game, some countries are in and some are out. And again, the ones that are out are actually better off. They're free riding. The ones that are in are better off than not having the agreement. They're glad they have the agreement, but they're not as well off as the free riders. Okay. Now, so this is the prisoner's dilemma. Now, this is the International Environmental Agreement. The equilibrium is still unique. It does not have a dominant strategy because whether you are in the agreement or not depends on how many others are in. Right? That's why some are in and some are out. It does not support an efficient outcome. And what's different here between the prisoner's dilemma is that the equilibrium is not symmetric. So some are in and some are out. Now that may bother countries because we may think it's unfair. You know, if we all start off as being similar, why should some of us be trying to, fix the world and the rest not? And if you inject concerns like that into the analysis, you can actually require that more countries participate in the agreement, but there's a cost to that. And the cost is you can only sustain cooperation if they do less and less. So as you widen the participation level, each country is doing less and less and less. And if you increase this enough, they're really not doing much more at all than they would have done without the agreement. Okay? Now, I'm going to come to Paris and COP21. That's what I think is going on there. All right, now in the climate negotiations, you want a treaty that does three things. First, you want it to have full or nearly full participation. You want everyone in, more or less. Second, you want the countries that are in to do what they said they're going to do. And third, you want to require them to actually do a lot. Now, of those three things, you need all three. 2 out of 3 is no good. So it's easy to have an agreement in which everyone is in and everyone's complying fully, but the reason is that the agreement doesn't ask them to do anything they wouldn't have done otherwise, okay? That's the Framework Convention on Climate Change for sure. If you start asking them to do more, then what tends to happen is countries will not join the agreement. The compliance actually, although people talk about it, I don't think is an important issue. If you take the Kyoto Protocol, which try to get countries to do, I wouldn't say a lot, but try to get them to do something, when the United States thought it would be difficult, they didn't sign at all, or didn't ratify rather. And when Canada, of course, Canada ratified, we have Canadians here, great country, we all love Canada. Canada, you know, Canada loves international law. I know you get tired of hearing this, you're nice, you know, so Canada ratifies, adopts no policies for meeting Kyoto, and then is way out of line for where it needs to be to comply. And instead of not complying, it just pulls out. That's how the international system works. Under sovereignty, they can pull out, and then they're completely in compliance with international law. The problem is we're not solving the climate problem. Okay. So what happened, that was Kyoto. What happened in Paris is to get an agreement, there's a kind of long story behind this, but basically you needed a consensus among all the world's countries. Now imagine that. How do you do that on any issue? Well, they did it, so that's the great achievement of Paris. But the fundamental reason they were able to do that is because all the obligations, or almost all of them, are voluntary. Okay? So the targets and the promises, pledges to make contributions are voluntary. Now, this is the analysis that came out from the UN Framework Convention on Climate Change Secretariat just before Paris. This is an assessment. This is supposed to be history. This is obviously some kind of cartoon of emissions. And the dashed line was a continuation. So that's basically their projection of where things would have gone were it not for the pledges that were made by countries, these INDCs they're called. And then they're projecting as a best prediction this red line for emissions. So what they're saying is the difference between the dashed line and the red line is the improvement you get because of these voluntary contributions. Now, one thing to say is, how do you know? Because you never get to see the dashed line. This is why I'm going to show you some experiments. You don't know what the countries would have done otherwise. But a more important point to make, I'm more a theorist than an empirical person, but I think that red line is going up. So if the slope is positive, this is bad. Global emissions are rising. By their own projections, under Paris, global emissions keep rising through 2030. Okay? You cannot stabilize concentrations when global emissions are rising, full stop. Now, they also produced an analysis, what would you have to do to meet their goal of limiting climate change, global mean temperature change to 2 degrees C. So this is history of emissions. This is the projection based on the INDCs. And this is what you'd have to do to have a 50% chance of avoiding 2 degrees C. So you basically have a sharp turn in 2030, which is more or less when Paris ends, or at least the INDCs end. So what is it that's going to happen in 2030? There's nothing in the agreement that's going to cause anything to happen in 2030. I call that a miracle. Now, it could happen, but the reason it's going to happen is because there's going to be some new kind of technology. Something else is going to change, but it's going to be from outside of this process. Okay. Now, how do you think about this? So I did an experiment with Astrid Dannenberg, again, who's a colleague I've worked with many times. And she's at the University of Kassel in Germany. And we wanted to see whether the design of Paris would make any difference. Now, the real novelty of Paris is you have the countries agreeing on a collective goal, which is easy for them to do because no one's responsible for meeting it. Okay? So when people get excited about the decision on temperature change, just bear that in mind. Then they make pledges for what they will do individually. And then finally, you're going to wait and see what they actually do, right? That's what we really care about. And what was different about Paris from anything that was ever tried before was they set up what's called a review process. So you make a pledge for what you're going to do, and then you're going to look at everyone's pledges and say, well, did you do enough or not? And then you're going to look at their contributions. Are you actually contributing as much as you pledged to contribute, and so on? And the idea is that this naming and shaming is somehow supposed to change behavior. Okay, that's the basic idea behind Paris. And I have to tell you, by the way, in the negotiations, as the countries moved towards a tougher global target, which no one's responsible for, they moved further away from what they could do in the review stages. Okay, that's sovereignty. It's just the way the world works. All right, so we did this. We wanted to see whether the review process would make any difference. So we can do this in experiments with people because we have the counterfactual there of what they would have done without the review process. And then we do experiments with the review process, and we compare the two and what's the difference. So what we find is, with the review process, the players choose a higher target, a better target, okay, which is what happened in Paris. They choose a better target. Secondly, they make higher pledges. So they're lifted up by the proposal to make higher pledges. Third, their expectations about what others will do goes up. Okay? So this is where you get the positive buzz out of Paris. But in the end, what we find is the review mechanism has no effect on contributions. And it's going to be very hard to ever tell whether this happens in the real world because we'll never know what would have happened without the agreement. Now, having said all that, the world has had some successes. So the question is, why? One of the greatest successes of international cooperation in human history was the eradication of smallpox. I know we're normally wanting to save species, but in some cases, I'm quite happy to let them go. And smallpox is one of them. And this good-looking young man, his name was Ali Maumalan, he was actually the last person to be infected with endemic smallpox. And he was infected in October 1977 in Somalia. And if he had not been discovered and isolated, and had the people with whom he had been in contact not been vaccinated, and had the people that those people had been in contact with not been vaccinated, and so forth, this disease could still be circulating today. So this is quite an astonishing achievement. But why did it work? Well, again, you have in this axis what the other countries are doing, and you ask yourself, what should you do? And in this little cartoon, this is normally what you would want to do, which is you're going to vaccinate to a certain level to control the disease. It may be at a fairly high level. So to eliminate the disease, you have to go to about 80, 83, 85%. So maybe this will be 60, 70, depends on the country. Some countries will eliminate on their own. This is the payoff you get if you eliminate it, though. For most countries, it didn't pay them to do it. They weren't doing it. But what happens here at the very end, everything changes. And the reason is, if everyone else eliminates, and then you decide to eliminate, you cause the disease to be eradicated. If you eradicate the disease, there's a big gain. And the reason there's a big gain is because no one's going to get sick in the future and die from smallpox, and you don't have to vaccinate. And that's a big gain. The vaccine was carried a lot of risks to it, and of course it was costly to use. So what you have here is a very different game from the two I've shown you before. This is a coordination game. In this game, there's one national equilibrium here where no one really does anything. And there's another one up here where the world coordinates to get rid of smallpox. This one is efficient. So that's why this succeeded, is because, this is the basic message of my talk, the world is very good at coordinating. It's very bad at enforcing cooperation in a prisoner's dilemma. So what I want to get to is, how can we find ways to coordinate on issues as opposed to try to do what we're not good at? Okay. So now I'm adding this next column. There's no longer the case that the equilibrium is unique. You've got two, right? One is that no one is eliminating the disease, and the other is everyone's eliminating it. There's no dominant strategy because what you want to do does depend on what the others do. There is a national equilibrium that is efficient, that's eradicating smallpox, and it is symmetric. So a lot of things about this make it very attractive. You can understand why we succeeded. I'm not saying that this was trivial or inevitable, it wasn't, but nonetheless, the basic incentives globally were in the direction of success. Now let's go back to climate change, because there's concern about dangerous climate change. That's what's mentioned in the Framework Convention. And this is just a table. I'm not going to go through it, but Tim Lenton and his colleagues wrote a paper in PNAS in 2007 where they basically said there are all these possible tipping points. He calls them tipping elements. Collapse of the West Antarctic ice sheet and melting of Greenland and the Indian monsoon and so on and so forth. So how does that change the game? Well, imagine that the game is about contributing and there's a threshold out there, and we know where it is. And provided each of us plays our part in avoiding the threshold, we avoid it, and we're all saved. Okay? So imagine that you had to contribute a certain amount, and then you divide that equally among symmetric, very similar players. Would they actually do it? Well, what happens here is that the game changes again at the very end. Because if everyone else makes their contribution, your contribution decides whether that tipping point is avoided, yes or no. So given that everyone else is doing what they should do, you want to do what you should do. Completely changes the game. And again, it's the green curve. The green is good. Red is bad. It causes the flip at the very end. And now you have, again, another coordination game. And you have a Nash equilibrium that is efficient. Now, what's cool about this is that coordination comes, like in the smallpox case, in a sense it's coming from Mother Nature. She's doing all the work for us. Okay? The problem is when you read the science on tipping points, as Alan told us earlier, is that the tipping points are uncertain. Now, how does human behavior change when tipping points are uncertain? So the theory of this, I think, is pretty straightforward. Suppose that everyone plays their part to avoid the tipping point. And now it's up to you to play your part. If you play your part, you avoid the tipping point. If you pull back a little bit, you actually don't cause the tipping point to be crossed. You only increase the chance that it'll be crossed by just a tiny bit. So now that damage that would have been incurred by moving away from the tipping point, instead of being discontinuous, is continuous. It's tiny. And so there's a tendency for everyone to pull back. So that's what the theory predicts. And when we go into the laboratory and test this, that's how people behave. So here's a paper I did with Astrid. I'm not going to go through all the details, but these two bars here are how 20 different groups, so 10 here and 10 here, performed when they faced a tipping point that was certain. And this is how they behaved, it's a different group of people, but how they behaved when they faced a tipping point that was uncertain. Now, if you avoid catastrophe, you should be blue. And if you guarantee catastrophe, you should be red. So the basic impression you get is very strong. When you face a certain threshold, everyone gets their act together, almost, and avoids catastrophe. When the threshold is uncertain, it collapses. And the reason is, here you have a coordination game. Here, you're back to the prisoner's dilemma. Okay, so behavior really is affected by this. By the way, you might say, well, hold on, there are two groups here that actually did have catastrophe. What happened there? Well, that was kind of fun to look into that. It turned out there was one person in each group who pledged to do their fair share, as it were, and then did nothing. These are the bad apples, I call them. But that was only 2 out of 200 people who were playing this experiment. Okay, that's a very low, I mean, I live in New York City, I'm very stressed out. Of course, because what Gretchen told us, but I ride the subway every morning, and I think the ratio of 1 per 100 bad apples, in New York I think it's higher than that anyway. Yeah?
The second column is labeled uncertain.
Yeah, it's, okay, so this paper was, there are 2 kinds of uncertainty. One is about the threshold. That's constant here. That's what I was talking about. There's also, the other one is about the impact. What happens if you cross the threshold? And what the theory says is that uncertainty about the impact should make no difference. And that's why these 2 look the same. The theory is completely right. It's amazing. These 2 look the same. So the theory makes very strong predictions, and you play it in the lab, and people, it's amazing how the behavior turns out. Okay. Now, we know from, Alan also talked about, and Simon talked about early warning signals, flickering and all that business. So what happens if we improve the science so that we knew we were coming up to a tipping point? So these are called early warning signals, although I think I'd prefer to call them late warning signals because you're going to get them before you cross, but there may not be enough time, right? Particularly on a problem like climate change. So the same theory can be used to show, if you put on this axis here, uncertainty. So here at 0, there's no uncertainty, you have certainty. Here you have a lot of uncertainty. That was the experiment I showed you before. But what the theory predicts is there'll be a sharp dividing line where to the left, uncertainty is so small, you have a coordination game. And to the right, it's big enough that you have a prisoner's dilemma. So the theory predicts there'll be a flip in behavior. So what's cool about this is you have a regime shift in nature bringing about a regime shift in human behavior. So we're talking about these coupled human environmental natural systems. It's amazing. We not only affect the environment, but how we understand the environment can affect our own behavior. Now, what happens when we go into the laboratory is people actually behave exactly as the model, or almost exactly as the model predicts. So they do the right thing, and they're making proposals and pledges and contributions to the left, just where they should. All of that behavior is efficient. Just to the right of the dividing line, you notice there's a discontinuous change in behavior. Now, the theory predicts that contributions should drop to here, and they don't drop that far, but these contributions up to this gray line here are very cheap. They actually cost the player 50 cents. So when it looks like they're being generous, they're not. To avoid the tipping point, you actually have to make expensive contributions, which is what we're going to have to do to avoid tipping with climate change. And they're not willing to do that, or very few. There are a few Swedes up here, but otherwise, there are not enough who are willing to do their part. So unfortunately, we can't rely on Mother Nature to create the coordination game. So that raises the question, can we create it ourselves? That's where the idea of strategy comes in. Okay, so now a topic that's related a little bit to what Jane was talking about last night. It's not quite a fisheries agreement, but it's very similar. This was an issue about the killing of North Pacific fur seals. They basically have breeding grounds on islands like the Pribilof Islands here and the Kuril Islands. They have a few different places. And then in the summer months, they would swim into the open ocean. And at that time, there was no exclusive economic zone, so you had the territorial sea of about 3 miles. That was it. And you had these pelts were very valuable, and you had open access. And every prediction you have from economics about how people behave is borne out there, where basically the harvesting was rapacious and the stocks plummeted, and you were moving towards, there were many predictions of extinction. By the way, you had this, this punishments and all that business that was going on. There was even the threat of war, I'm not making this up, between the United States and Japan over this. And very strong, very tight, very powerful tensions between the United States and Canada. Well, they negotiated an agreement that changed everything. So you go from one world in which is complete collapse, and we're behaving very, very badly, and then another world in which everything goes fine. And what happened was the agreement turned a problem that wasn't a coordination game and made it one. So this is cool. So this is the first strategic treaty I've ever found. And what the agreement said was that none of the states, so this was the United States, Canada, Britain acting on behalf of Canada, Japan, and Russia. None of the states could kill seals at sea. So the only states that could kill seals had their own breeding populations. And that killing was very, it sounds cold-blooded for me to say, but it's very efficient, okay? You don't waste, and it's also less expensive. And the key thing about the agreement was anyone who violated the agreement would not be able to export their pelts to Great Britain, where all the pelts were being processed for those handsome coats we saw on the previous slide. And that trade restriction deterred entry by third parties, new countries. So that it's almost like closing the sea. No one else came in. That's what made it work. And the whole history of this told us that if all 4 countries, so that's the US, Russia, Japan, Britain on behalf of Canada, so that's basically one country, all 4 countries, if they did what they're supposed to do, no country wants to pull out, because if they do, they know from the whole history the stock is going to collapse and their rents are going to go to zero. Even one country would cause the whole collapse. So that's why you get a coordination game. So again, if everyone else is in, the best thing for you to do is to be in. And this agreement was very stable and has worked very well. Ozone, another example. How am I doing on time? I have this tendency to go on forever. And Okay. So another great success story is the ozone layer, which I think people have not fully understood how we were able to protect it. This is the latest image of what the peak of the ozone hole looks like over Antarctica. Now, if we could have looked at this game as a prisoner's dilemma. That would have been fairly natural, I think, that we want countries to phase out CFCs, and we're all better off if we do it, but countries might feel they're better off letting others do it and not doing it. So it should be, we could have looked at it as the classic problem where the players were to reduce their consumption, meaning production plus imports minus exports. That's actually how the Kyoto Protocol was designed. Montreal's much better. Montreal is another strategic treaty. Okay, it's like the first field treaty that way. How does it work? Well, first of all, they're limiting not just consumption, but also production. Do you have a climate treaty that limits coal production anywhere on the planet Earth? No. There were side payments. These also existed in the first field treaty, making sure that all the parties were better off with the agreement than without it. Okay? And finally, and very importantly, you also had a trade ban here. Here, the countries that were outside the agreement were not allowed to trade in the CFCs, products containing CFCs, et cetera, with the parties that are in the agreement. Okay? And what this did was it transformed the game that would have been a prisoner's dilemma if we approached it that way, which is how we approach climate change, and made it look like this. So in this game over here, what happens is this is the payoff this is the decision to join the agreement or not. So it's like the treaty game I showed you before. This is the payoff you get by not participating. And this is the payoff you get by participating. So initially, if very few others are in, you don't want to be in because not only is there the normal free riding, but on top of that, you can't trade with the other countries. And there are a lot of them. You're on your own. But as you move in this direction, things flip. And you've created a tipping point. We have created one through the treaty. And what happens is, as long as a critical number of countries are in, you want to be in. So think of it, if you're over at this level here, if you stay out of the agreement, you benefit because you can free ride. So normally you'd want to do that. That's why the prisoner's dilemma, those curves never cross. But now, if you pull out, you can't trade with the other countries. Okay, so what happens in this agreement, this is a beautiful agreement. I told you about the problems of punishment. This agreement, the trade measures are strategic, meaning that the prediction of the theory would be in equilibrium, trade will never be restricted. But you'll have full participation, everyone doing everything, and the agreement working perfectly, which it has. Okay? And people don't talk about this because anything that works, people just pretty much ignore. We always focus on the things that don't work, and people think they understand this agreement, and I don't think they have. This here is a story about trade, which I don't really need to tell you about. Another one on the oceans. There's an agreement, I can never remember what it stands for, but everyone calls it MARPOL. It's got a long name. It's something. It's complicated. Yeah. It's right. Okay. MARPOL, marine pollution. Good. I don't know what it is about my brain. I can't do acronyms. I have figured out the UNFCCC, they call it. The IPCC. I used to be on that. So those I can do, but that's about it. Okay. So this is all about dumping oil in the sea, and we used to do it deliberately. All the time, routinely. So you would have an oil tanker, you fill it with oil, then you drop off your cargo, and then when you make the return journey, you have to fill up the tanks with water for ballast. And then before you pick up the next load, you have to flush out the ballast water, and all this oil enters the ocean. And we were just doing this all the time, deliberately. And the first negotiations on how to control this began in the 1920s. Okay? And they wanted to do it in the way you would expect them to do it. Let's treat this as a prisoner's dilemma, and let's ask everyone to stop doing it. And funny enough, they didn't. They kept doing it. And these negotiations went on for 50 years. I think it's kind of a nice story to remember because the climate negotiations have been going on for about 25 so far. And in the 1970s, they came across a very different idea. And the different idea is, let's design the tankers differently and require that this new design be adopted. And the reason that can transform the game, so the new design was, and this is actually what they look like today, so you had to segregate where the oil would go from where the water goes. And they changed this regulation later to have double hulls, which is obviously protecting oil spills in the event of accidents. So this is water here. So if there is an accident, you should get water coming out, ballast water, rather than oil. Now, the reason that this worked, this was the old way they were approaching it, which did not work. They confronted the prisoner's dilemma directly. We're not good at that. With the technology standard, the reason that worked is if you only allowed into your port the tankers that meet the new standard, then your own coastal waters will be more protected. And as more tankers meet the new standard, that becomes a very easy thing to do. Likewise, if you're a tanker owner, the more ports restrict access based on the technology, the more you want to meet the new standard, because otherwise you'd be denied access. So you get this flipping, this tipping behavior again, but now it's over the technical standard. And what happens is this is the payoff you would get to not switching. So it's this curve being bent around because essentially another trade measure, right? And this is the payoff you get if you switch. Initially, there's a big cost because the cost of refitting the tankers, and you lose some space that could have been used for carrying oil, now has to be empty. But everyone's better off here, and you have another coordination game. What's different about this one than the Montreal Protocol is that it's not efficient. See this gap here? If you could enforce cooperation here, you would have done better. So this is what's called second best. And remember, it took 50 years for them to get to this. I'm leading up to climate change. We've already spent 25 years. Okay, so I think there's something about human behavior that we want to have something that's ideal. And we pursue the ideal, and we don't make it. And we just keep trying and trying and trying. So what happens here, the equilibrium is not unique. It's another coordination game. There is no dominant strategy because it can't be if that's not unique. It's not efficient in this case. That's what's different about this one. The outcome is symmetric. Now, I've been curious about why is it, because I've been talking about doing this for, my first paper I wrote on this was around 2000. You can see how much influence I've had in the world. And I wanted to ask the question, if you could look at the problem as the prisoner's dilemma, which is this game over here, or as a coordination game, which I'll explain this in a second, which would you choose? So you're going to choose between A, which is the prisoner's dilemma, or B. Now, there are two versions of B. This is the payoff you get if you don't switch the tanker design. And in one scenario, you get this payoff if you do. So it's like the other picture. Initially, you lose, but later you would gain. Okay? And this one is efficient, so it's more like Montreal in that sense. And this other one here is what I would draw if you have the second best. So the behavior is still, the incentive is not to switch as long as the critical number of countries that don't switch is over here. But if you get past that tipping point, everyone wants to switch. You have a coordination game. But what I want to know is, do people behave differently if it's efficient or inefficient, second best? Okay? So Astrid and I did another experiment. This is what the result we got with the efficient one. So this is the one where this is the payoff to not switching. This is the payoff to switching. Okay? And that's efficient. So in other words, you can do as well here as over there. So what happens here, if you look at this, you see a few things. So you have here on the number of rounds that they're playing contributions. And this over here is the level of their contribution. Okay? So when you see it at the top, everyone's contributing everything. So the first thing you see in this picture, when they play orange, that's the coordination game. That's B. And when they play blue, that's the first game. That's the prisoner's dilemma. If you look at the first stage when they decide what to do, and they're going to be voting on this, half the groups play the prisoner's dilemma, the A game, half play the coordination game, the B game. So it's almost as if it's random. After that, everyone plays the coordination game, the B game, and no one ever goes back. Plus, coordination is nearly perfect. I mean, here you see, okay, there was one player that didn't coordinate, and then quickly did, and then, a bit cheeky, went back down again, but then came back up and it was perfect. And look how many of these are completely perfect. People are very good at coordinating. This picture here, in my opinion, is the Montreal Protocol. Okay? It worked beautifully, and that's why we did it. It went with the grain, as it were, of the incentives. Now, I'm going to show you I know, I'm almost done. So now I'm going to show you how people play in the other one, the B8 game. And you want to see, is it different? It's very different. So what happens now is everyone goes for the Prisoner's Dilemma, the A game. Everyone. Over time, some groups try to switch. When they do switch, they coordinate perfectly. Every group that switches coordinates perfectly. But some groups maintain this traditional pattern of the Prisoner's Dilemma, declining and declining and declining. Half the groups never switch. Remember how long it took for people to rethink Marpole, or that, the oceans problem. And I think what you see in this kind of behavior here, this is much more like climate change and how we're dealing with it. We're not dealing with it very effectively. So the question is, how do you get people to imagine the game as a coordination game? And we have not approached the climate problem, or indeed other problems, generally speaking, in that way. There are ways that you could do it. And by the way, this is not to say we should get rid of the Paris Agreement. I have no problem with the Paris Agreement. It just won't be enough. But we could build agreements around it. And there actually are efforts underway now to do that. One is to limit hydrofluorocarbons, which would be done under the Montreal Protocol, which is a coordination game, so that will work. But the thing is, we could have done this ages ago. I recommended this 15 years ago. And we've been wasting all this time because everyone's trying to pursue the Prisoner's Dilemma for climate change. Limits on aircraft, people are talking about that now. We need to make more progress. We can break this out into other sectors and look for opportunities for coordination. So the conclusion is the international system has trouble sustaining cooperation in the Prisoner's Dilemma because we're just not good at enforcement. We are very good at coordinating. So rather than look at these problems as prisoner dilemma games requiring enforcement, why don't we start to think, can we look at them as coordination games? Then I think we'll succeed much better. Thanks.